let's just move on further towards the new topic, and I hope representing a real number on the number line is all clear to you. So the next particular topic is nothing but real number and decimal expansions. Now with the help of the decimal expansions, we will categorize the real numbers as a rational number or as an irrational number. So we have actually classified all such kind of numbers into, the first number would be like terminating and a non-repeating decimals. So the first decimal representation, or we can say the first number that we can classify in the decimal expansion and real number topic is nothing but terminating and a non-repeating decimal. So we can also call it as a terminating and a non-recurring decimal. In place of repeating, we can also use a word recurring. So a terminating non-recurring decimal. What is the meaning of a terminating and a non-recurring or a non-repeating decimal? So any particular number in which, or in any, or a particular rational number in which after solving it or after dividing both the numbers, we are getting the remainder as 0. It means that it is terminating as well as non-repeating. So let us suppose I'm talking about the number, rational number half. Let us suppose I'm talking about 1 by 2. So if we are dividing 1 by 2, it means that the division of this would be like 2 and 1. So point will be like 0. So 2, 5 and 10. So it is terminating, means the remainder over here is nothing but 0, and there is no repetition which is in the quotient. There is no repetition in the quotient. There is the remainder of this particular rational number is nothing but 0. So any number which actually terminates, or the remainder of that particular number is nothing but 0. So such kind of numbers or such kind of real numbers are nothing but called as the terminating and the non-repeating decimals, in which their quotient do not have any such kind of a number which is having a repeating string of numbers. So such numbers are called as the terminating and the non-repeating or the non-recurring decimals. So the representation 0.5, or we can say half, is nothing but a terminating and a non-repeating decimal because they are giving the remainder as 0. So let's just further talk about the next type of the numbers, which is nothing but non-terminating and repeating decimal, or we can say the recurring decimals. What does it mean? The numbers which are non-terminating, it means that the remainder of such numbers is not 0. The remainder never becomes 0 with the repeating string of numbers, means the quotient do have a repeating string of numbers. Let us suppose I'm talking about the number 1 by 3. Let us suppose I'm taking 1 by 3. So let's just divide 1 by 3. So it would be like 3 and 1. So it is point. So it is 0. So 3 3s are 9. The remainder would be 1. Again 3 3s are 9. So the remainder is again 1. So it means that the number will never get terminating. The remainder will always remain 1, and the quotient will be 0.33333, and so goes on. The process still continues on because the remainder of this particular number cannot be 0. So such kind of the numbers in which the remainder can never be 0 and they do have a repeating string of numbers in the quotient. These are the repeating strings. These are the repeating strings of numbers that are still going on without terminating. So such kind of a numbers are nothing but called as non-terminating because their remainder can never be 0. Repeating because the numbers are repeating in the quotient. There is a repeating string of numbers. So such numbers are called as non-terminating, recurring or repeating decimals. So these numbers are categorized as these kind of numbers. So let's just move on towards the third kind of numbers, which are nothing but non-terminating, non-repeating decimals. What does it mean? It means that the numbers which are non-terminating, they are not terminating at all, and they are even not repeating as well. So such kind of numbers are nothing but called as the non-terminating and the non-repeating decimal. Let us suppose I'm talking about a decimal which is let us suppose 1.0010010001000 and so goes on. So such kind of a number is actually not terminating at all, because the remainder of such kind of a number can never be 0, and there are the string of numbers, or we can say that the numbers in the quotient, they are not terminating, but they are even not repeating themselves. For an instance, if we are talking about this number 0.333, we know that the number 3 is repeating itself again and again, but over here no such kind of a pattern we can able to see in this particular number, because any string of numbers, they are not repeating itself again, because the numbers are all in different pattern. As we know that there are 2 zeros, there are 001, this is the 001, but again the number is not repeating itself because it is 0001, so it is quite different from this number. So again the number is 000 and so goes on. Such kind of a number in which we have a non-terminating and a non-repeating decimal, these are called as such kind of numbers in which, always remember, the remainder can never be 0 with no repetition. There is no such repetition of the string of the numbers, and the remainder can never be 0. So we can also say that the numbers square root 2 and pi, both of these numbers are nothing but called as the non-terminating and the non-repeating decimal, because the value of the root 2 is nothing but 1.413 and so goes on. The numbers can never repeat itself. Moreover, the remainder can never be 0 in case of the root 2, and similarly in case of the pi, because the value of the pi is nothing but 3.14, so goes on. The number is non-terminating and the non-repeating decimal. So these are the classifications of the decimal expressions, in which we have 3 classification of numbers. The first one is the terminating, non-repeating or the non-recurring decimal. The second one is non-terminating but a repeating decimal, and the third one is the non-terminating, non-repeating decimals. So let's just categorize the decimal expressions again in terms of the rationals as well as the irrationals, because we know the definition of the real numbers is that the real numbers are nothing but those numbers which consist of rational numbers as well as irrational numbers. So with the help of the decimal expressions, we can categorize them as rationals and irrational. So let's just start with the very first number. As we know that the number in which the remainder is equal to 0, such kind of a number is nothing but called as a non-repeating and a terminating one. So let us suppose I am writing over here as a non-repeating and a terminating number. So such kind of numbers which are the non-repeating, which are the non-repeating and the terminating one, they are categorized as the numbers which are called as rational numbers. So any number in which the remainder is 0 means it terminates, and the string of the numbers or in the quotient, they are non-repeating numbers. So such kind of a numbers are nothing but called as the rational numbers. It is called as the rational number. So let if for example, I'm talking about the number half. So the number half is nothing but 0.4. So as we know that this number terminates, it provides the remainder as 0, and there is non-repeating, there is no repetition of the numbers over here. So such kind of a number is nothing but called as a rational number. So 1/2 is nothing but a rational number, 1/5 is nothing but a rational number. So let's just move on further towards when the remainder is not is equal to 0 and the number is repeating. There is a string of number which is repeating itself, and furthermore it is repeating. Furthermore, it means that they are non-terminating. They are non-terminating, because we know that if the remainder is not is equal to 0, then definitely the number will be non-terminating. So such numbers are considered as to be rationals again. These are rationals again. So let us suppose I'm talking about the number 1/3. For example, I was talking about the number 1/3 in the previous slide. So 1/3 is the number which is 0.33333 and so goes on. So such kind of a number in which the remainder is not equal to 0 and it is repeating itself, or there are some string of numbers that are repeating, such numbers are called as rational. So we have categorized such numbers as rational. So always remember, a terminating and a non-repeating and a non-terminating repeating numbers are always categorized as the rational number. So let's just move on towards the third decimal expression, in which we have talked about a number in which the remainder can never be 0 and it is non-repeating. So I'm talking about a non-repeating and a non-terminating number. So a non-terminating number, we are talking about these numbers, like we have given an example of a number which was like 0.001, 0001, 00001 and so goes on. Such kind of a number in which there is no repetition of the numbers and there is the number which is non-terminating, which is actually not providing the remainder as 0. Such kind of a numbers are nothing but called as the irrational numbers. So always remember this thing, that whenever in any particular decimal expression remainder is not equal to 0 and it is non-terminating, so such kind of a numbers are nothing but called as irrational numbers. So let us suppose I'm talking about the number root 2. If we are talking about the number root 3, root 5 and pi, so all these numbers are nothing but are all irrational numbers. So all of these numbers are nothing but irrational numbers. So these are the three categories of the numbers which are actually giving us the answer as whether, if we wanted to know that a particular decimal expression is a rational, is a irrational, so we can use these three things. If the number is a non-repeating terminating, it means it is a rational number. If the decimal expression is a repeating and a non-terminating, it means it is a rational. And if the decimal expression is of the kind non-repeating and non-terminating, then it is definitely an irrational number. So I hope the concept of categorizing the real numbers in terms of rational and irrational decimal expression is all clear to you.